Assalamualaikum and hi everyone. So today we are from group 1. In this video, we will present you about Mohr circle. I'm NURHUWAIDA BINTI SHAHRUL NIZAM from 5BME1. We'll begin to introduce you what is Mohr circle. So basically, the stress transformation equation were developed to calculate the stress state at different orientation. These orientation were normal stress at x and y axis, and orientation of shear stress at x and y axis. So in 1882, a scientist named Otto Mohr noticed that this relationship could be graphically represented with a circle. This graphical representation is extremely useful because it enables you to visualize the relationship between the normal and shear stress acting on various inclined planes at a point in a stress body. Using Mohr circle also can be used to calculate the principal stress, maximum shear stress, and stress on inclined planes. So, to determine the actual equation for Mohr circle, the previous stress transformation equation be rearranged to give an equation like this picture. After that, each side of this equation can be squared and then added together to give an equation like in this picture. Grouping similar terms and cancelling other terms give an equation to be more simplified like this picture. Using the trigonometry identity, which is cos squared 2 plus sin squared 2 equal 1, give an equation like this. This is basically an equation of a circle. The circle equation can be better visualized if it is simplified to give an equation like in this blue picture. So basically, this equation were used in Mohr circle equation. So lastly, the circle equation is plotted at the left using radius and normal average shear stress. So there are some important points that must be noted for graphical analysis by Mohr circle. First, the normal stress are plotted along the abscissa. The tensile stress are considered positive and compressive stress are considered negative. The shear stress is plotted as ordinate. Shear stress, which causes clockwise rotation of element, is considered positive, while other one, which causes anti-clockwise rotation, is considered negative. Coordinates of various points on Mohr circle represent the state of stress at different planes. The radius of circle to any point on its circumference represents the axis directed normal to the plane, whose stress components are given by the coordinate of that point. And lastly, the angle between radius to point on Mohr circle is twice the angle between the normal to the actual planes represented by this point. The rotational sense of this angle is same as that of rotational sense of the actual angle between the normal to the plane. So that's all from me. Thank you.
My name is Muhammad Amin bin MAZALAN, and I'm as a second presenter, and I'm going to present about Mohr circle example.
Okay, Assalamualaikum. In this video, we gonna do stress transformation with Mohr circle, and Well, given that the state of stress here with value of normal stress is 20 megapascal, 10 megapascal, and shear stress of 30 megapascal, and what we gonna find are principal stress and representative value element A, and at the left one I have been summarized the process that I like to use to drawing more circle. Okay, the first thing that I want to do is establish the local coordinate system, and technically you can use any direction for x and y. Wait, let me choose a color first. And okay, to start it off, I'm gonna start with x is horizontal and y is vertical. This is important so we can define our stress, so that the next thing to do is define stress, and with our coordinate system that we have, sigma x, because its causing tension is equal to 20 megapascal, and sigma y causing compression on the stress element, so it is negative 10 megapascal, and shear stress is positive 30 megapascal. Okay, then we need to draw the chord axis, and wait, let me adjust this first. Okay. Okay, then we need to draw the coordinate axis here, because I don't know my Mohr circle is gonna be with respect to 0, so I just gonna draw horizontal axis to represent my normal stress. So this is sigma axis, and before I do that, I'm gonna determine that the center of my Mohr circle, center is center average, comma 0, and sigma average equal to sigma x plus y divided by 2, which is in this case will be 20 plus negative 10 divided by 2, and that is 5 megapascal, and that means my center is located at 5,0 megapascal. First point on the outer radius, which is I will call A, is sigma x tau xy, same with coordinate of 20, 30 megapascal. On the paper, I would like to draw the circle first, and on my center has coordinate of 5,0. As you can see, the A point is 20,30, which will be the estimate around somewhere here at the A point. The next things I want to do is calculate the radius, and the radius is just by using the Pythagoras theorem, and then we can get. Now that you have been able to draw more circle and calculate more radius, a lot of problem ask for the principal stress. The principal stress are the maximum and minimum normal stress associated with the element in the Mohr circle. That is, just here is maximum normal stress sigma 1, and here is minimum, I call that sigma 2. If I want to calculate sigma 1, and since I know that the sigma average is 0, sigma 1 is just sigma average plus the distance to the point, which is the radius of the circle, and average of sigma 2 is average minus radius. Let me make it bigger a little. Okay. Another piece of information that important for me is the angle rotation I need to get to this principal stress, or to orientate my element in principal, and this is I call it alpha. So I use inverse tangent tau xy of over sigma average and the angle associated sigma 1 will be P1 alpha divided by 2. This will be anti-clockwise. And we also can calculate sigma 2 right here. I call it beta. Beta is just 180 minus alpha. I can calculate P2 beta over 2 clockwise. In principal stress state, I remember that theta equal 0 was established as horizontal, theta equal to 0 degree. Here will be theta P1, and I would like to draw a line perpendicular to this right here, and the rest of the box square, and this theta P1 will be pointing to my sigma P1 value. So I will have a stress here, sigma 1, and there will be equal opposite to the other side. The sigma 2 is also positive, which is 180 from the sigma 1 will be 90 degree.
Warahmatullahi wabarakatuh. So continue the lesson about Mohr circle. Next we go to the question given to test for the Mohr circle. And my name is WAHYU ALWIE bin YUSOF and I from 5S BME 3. So here we got several question about the Mohr circle and we use the value given. And for the first question is find the average stress. The second one, find shear stress maximum. Next, we need to find the sigma 1 and sigma 2. And the last question is find the angle. So for the first question, find the average stress. So for this question, the first step we need to do is we need to draw a graph and the circle. And here we have the value for the x-axis and y-axis. And next, we need to know the distance from the x-axis and the y-axis. So here we have 550 and 400. We need to plus this value and we got 900. And then the 900 we need to divide by 2. Why divide by 2? Because we have two parts for this value. The first part is 550 and the second part is the 400. So that's why we need to divide by 2 and then we got 475. And to find the specific value of the average stress, we need to minus by 400. Why 400? Because we already know the value of the x-axis and then we got a 75 megapascal and we need to put negative. Why negative? Because they are on the left side of the x-axis. Next question is find shear stress maximum. And for this question, we need to know that shear maximum is known as radius. And we can use the equation given and we put the value that we got. So for the first value, we have 475, the power of 2, and plus by the 530, the power of 2. And we got the final answer is 711.706 megapascal. Next, I will pass to our team member.
Bismillahirrahmanirrahim. So my name is FARHAN ROSLE from 5ME1. So I'm going through for the question number 3 to find the sigma 1 and the sigma 2. So first of all, as you can see on the straight line, there is a 2 point, the left side and the right side. So the point on the end of the right side is the sigma 1 and the end of the left side is the sigma 2. So to calculate the sigma equal to radius minus the average stress. So we put all the value and we got the 711.71 minus 75 equal to 636.71 and the unit is MPa and the sigma 2 is 711.71 plus 75 equal to 786.71 MPa. So sigma 1 is on the right side because it is positive, so we need to minus, while the sigma 2 is on the left side, so we need to plus 75. And for the last question is to find the angle. As you can see on the picture below, there's a red circle. So this is the angle we need to find, the angle on the center point. So based on the Pythagoras theorem, we get that tan theta equal to 530 over 475. So to find theta equal to tan -1, power of -1, bracket 1.116. And we got the first answer is by drawing. This is 48.18 degree. So when we need to change into the real world size, we need to drawing size over 2 to get the real world. So the answer is 24.07 degree, the final answer. So that's all for the equation on this equation given. As a conclusion, everybody know the Mohr cycle is in a geometric represent as 2D stress. So this Mohr cycle is often used in calculating stress in many places. So that's all for me. Thank you.